In this webinar, we'll be looking at how you can visualize metabolomics and gene expression data using the Omics Viewer. I'm Peter Midford, a member of the Bioinformatics Research Group at SRI International. This webinar assumes you are familiar with the cellular overview and its operations discussed in Part 1 of this series. The Omics Viewer is a tool to visualize the activity levels of many different metabolic pathways based on omics data. Here is a demonstration of the Omics Viewer animating data. This is from a gene expression omnibus dataset showing the response of E. coli at 6 time points over 10 minutes after oxygen becomes available in the environment. Although this is gene expression data, we're showing the gene expression overlaid on the reactions catalyzed by the products of those genes. I'll be showing you how to create this display and numerous other ways to look at this data. I'll start by showing how to load omics data from a local file and discussing the format for the data file and identifiers in the file. Once the file is loaded, I'll demonstrate static displays of omics data, animation of time series, and omics data windows for individual reactions. I will also show omics data on a pathway page and how to generate a table of pathway diagrams with omics data. I've already logged into BioCyc.org and selected E. coli as my current organism. Now I'll open the cellular overview from the metabolism menu. Now let's look at the top section of the operations menu, which we skipped over in the cellular overview webinar. This section lists a number of ways to load experimental data into the viewer, but we'll focus on the first method, uploading data from your computer. For demonstration, I'll use a file of gene expression data from a study of response to changing oxygen concentrations in E. coli. Here is the top of the file in the text editor. We've filtered out from this file genes for which the change in expression was either statistically insignificant or small in magnitude. The file must be in the following format. Aside from the comments at the top, there is an optional row of column names which must start with a $sign character. This is followed by rows of tab-delimited data. It is important that the columns are separated by tabs. The software won't accept comma-separated data. The first row should contain a name or database accession ID that identifies the gene. Actually, BioCyc provides some flexibility in how the genes can be identified. Here's an example data file where the E. coli B accession numbers are used instead of gene names. And this is a file that demonstrates different formats for identifying genes. The first line shows how multiple identifiers for a gene can be combined using a $sign character. This format allows you to specify multiple possible ways of recognizing a gene. The second line adds a third accession ID that EcoCyc knows about. The third line demonstrates an identifier containing an underscore character that separates the name or ID of a database from an identifier used within the database. BioCyc will use the portion following the underscore character as the identifier to use. The fourth line is an error since the gene name and B accession ID don't match. If this file is loaded, the system will notice this, flag it as ambiguous, and ignore the line. I'll pop back to the browser and show you how to load this file. To start, just select the Upload Data from File item in the Operations menu. This will bring up a dialog where we provide more information to guide the processing and display of the data in the file. This dialog has several choices that I will go through. Note that many of the choices have help buttons that pop up hints and additional information. Although this file actually contains a time series, I will start by loading a single time point to demonstrate some of the features of the overview display. Then I will reload the file using all 6 time points and demonstrate animation. The first line in the dialog provides a button to open a file chooser that lets me browse to the file. Here is the file, and the preview panel in the chooser shows I have the same file that I showed you. The next line in the dialog asks what kind of identifiers are in the first column of the data file. Since the default is gene names and identifiers, there's no need to change. But note that the viewer can load data about proteins, compounds, or reactions as well. The field to the right lets you specify which columns contain the data values. You can provide either a list or a range of columns. Because the first column in the file containing gene names is counted as column 0, I will choose column 1, which corresponds to gene expression values at the first time point. The next line asks if data are relative or absolute. This choice asks whether each data point represents an absolute value, such as a count, or a relative value, such as a fold change over baseline or normalized ratio of 2 values. Choosing a relative value allows several options that make sense for ratio data, but not for absolute data such as counts. First, relative data, unlike absolute, does not assume all values are greater than 0, so it provides an option to display data values on a 0-centered scale, rather than the 1-centered scale appropriate for absolute and some relative data. The Omics Viewer actually ignores values less than 0 when interpreting data as absolute values, which you should be aware of when choosing relative versus absolute data display. Choosing relative data also enables the option to display data calculated as the ratio of 2 columns in the data file. In this file, the data is a set of counts of RNA transcripts, so an absolute measure is the more appropriate choice. And you'll notice the options for scale, center, and ratio of columns are removed when I choose absolute. The next line asks for a color scheme. A color scheme is a combination of a color range and the presence of a cutoff or threshold. There are 2 available color ranges. The default is orange, gray, blue, and there is an alternative red, blue, green. For each range, the first color corresponds to high values, the second to values near 0, and the final choice is for large negative values. There are also 2 cutoff options. The first is to set the maximum value in either direction from the data provided. The cutoff option allows you to specify a maximum value, usually smaller than the maximum value in the data, that defines the range. This compresses the range so a few small values don't hide small differences. Choosing the cutoff option causes a field to appear below the color scheme choice, so you can enter the cutoff value. I'm going to choose a cutoff of 3000 here. Most of the values in this data set are less than 3000, and by choosing a cutoff of 3000, the magnitude of these outliers does not mask the variation among the majority of the gene expression data points. Note that the cutoff does not remove data points over 3000. They are displayed at the orange color extreme. The final color scheme option just consists of 3 colors: a high color for everything above the threshold, a low color for everything smaller than the negative of the threshold, and a middle color for everything in between. The next field asks how to display the data. There are 3 separate visualization tools available. The first overlays omics data on the full metabolic cellular overview diagram. The second generates a table of pathway diagrams. There's also an option to show both of these on separate tabs. The third option displays omics data on a multi-pathway diagram called a pathway collage. Pathway collages are the subject of a different webinar. You'll find links to it as webinar number 6 on the BioCyc webinars page. For this demonstration, I will use the option to show both the omics overlay and the table of pathway diagrams. Because I've selected the pathway diagram table as one of the outputs, it asks how many pathways to put in the table. The table orders the pathways by a value we call the pathway perturbation score. I will choose the top 10 pathways. The final field selects a format for omics pop-ups, which are small graphs in windows that can be invoked from the mouse over of a reaction or a compound with omics data. I'll leave this option alone for now. When I hit the Submit button, the browser first takes me to the new Pathway Table tab. I'll switch back to the cellular overview to start. There are now 2 new tables on top of the omics display. On the right is the omics data report table. This is a diagnostic table that provides statistics about the input file. The first part shows how well BioCyc did at recognizing the names in the file. So we can see that of 639 genes, 640 minus the header line, 2 names weren't recognized. It also shows that there were no ambiguous names, and all data values were usable. If there were problems reported here, it might be worthwhile reviewing and cleaning your data file. Below that is a table showing some basic statistics for all the genes retrieved from the data file, as well as a subset of genes that can be tied to reactions that appear in the cellular overview diagram. Besides the number of genes shown in the display, the min and max values are probably the most useful of these statistics. After reviewing this window, as there are no problems, I will just close it. The other window is the Omics Viewer control panel. On the left is a color scale running from 0 to our selected cutoff of 3000. Let's take a quick look at the overview diagram. Reactions that correspond to genes that were recognized in the data file have been overlaid in the color appropriate to the omics value in the selected data. Since this is an overlay of the cellular overview, the scroll and zoom commands work as they do in the overview. Likewise, the 3 sliders controlling opacity, edge thickness, and highlighted edge thickness work the same. I'll set the highlighted edges to be as thick as possible so you can easily see which reactions correspond to our gene expression data. If I scroll around, I find a reaction with a high value, which happens to be in the L-threonine degradation pathway. If I mouse over this reaction, I see the Windows title bar contains, in addition to the Keep button, an Omics button. The Omics button opens up an Omics data window that we'll take a look at when I load the full time series. If I click on the pathway link, it will take me to a page detailing the pathway. Notice that the omics data values are also displayed as colored squares next to each reaction that has omics data. This is just one pathway, but waiting for us on the next tab is a table of 10 pathways with omics data. This page shows a table of the top 10, because that's what I asked for, reactions ranked by their perturbation score. The page starts with a description of what the perturbation score is for reactions and for pathways. Intuitively, the perturbation score is the measure of activity in a pathway or reaction. For a reaction, we take the largest absolute value of any data associated with the reaction. In our case, this is the largest gene expression value of any enzyme involved in the reaction. Then we combine the reaction perturbations by using a special averaging function to combine the perturbation scores for each reaction in the pathway. The color scale is also included here for reference. The table itself shows the pathway name, the diagram for the pathway, the perturbation score for the pathway, and information about the genes and enzymes associated with every step in the pathway, regardless of whether there is omics data for the corresponding reaction. Notice that the pathway diagram includes labels for genes and that each gene with expression data is accompanied by a small box colored appropriately for its expression level. Unsurprisingly, the L-theanine degradation pathway we looked at in the overview diagram is here. Before I move on to time series, I'll show you why it is helpful to compress the color scheme by setting a cutoff. First, I'll close this tab with the pathway table and then go back to the omics overview. First, notice the range of colors in the control panel extends to 3000 as we had specified. Now I'll focus on the fermentation and respiration pathways and point out a few reactions upstream of the TCA cycle. And notice that the highlights are spread out throughout the color range. Now I'll quickly remove and relabel the omics data as before. But this time I'll show what happens if I don't compress the data in the color scheme. Notice the change in the values and the color range in the control panel. Values range up to 7,228 and beyond. Looking at these reactions in respiration, most have turned gray or almost gray, although a few reactions in fermentation remain orange. Most of the resolution for intermediate values has been lost. This is why it pays to experiment with scaling color ranges to achieve the most informative display. Okay, let's look at the full time series for this data set. To reload the data, I start by removing the previously loaded data by clicking the Remove Omics Data button and confirming in the dialog that appears. Now, I go back to the Operations menu and select the Upload Data item again. I choose the same file from the dialog. Again, the default for identifiers in the first column is correct, so I move to the Data Columns field. Here I will specify a range of columns in the Data Columns to Use dialog. Since the data is in the 6 columns following the gene identifiers column, I'll enter the range 1 to 6. Again, since these data are transcript counts, I'll choose absolute data. Likewise, I'll choose the default orange color scheme with a cutoff of 3000. And I'll request both an overlay on the cellular overview as well as a table of diagrams. And this time I'll select the top 20. Again, I'll ignore the omics graph format field. When I switch back to the Cellular Overview tab, note that the Omics Data Report window does not appear. This is why it is good to explore a few single data columns before loading a full time series data set. Since we've already reviewed the first column, let's move on to the control panel. Because this is time series data, there's now an added animation player with stepping and playback buttons. Before running the animation, this is the appropriate time to look at the Omics pop-up. So I'll find the L-thymine degradation pathway again and mouse over the high-valued reaction. With the pop-up open, if I click the Omics button, I get a new window that shows a simple bar graph with the Omics data from the file. Because the dataset contains multiple time points, the bar graph that appears will contain multiple bars. Each column is labeled by the column number on the x-axis, and the y-axis is labeled with the name of the gene. I can mouse over the bars to see the exact value for each time point. The data window won't disappear if I move the mouse away. Instead, there's a close button on the title bar for that. We can change the formatting in this window by clicking on the Preferences button over in the Control Panel window. There are options for changing the format of the graph, changing the x-axis labels between column number and column label, scaling and font size, and whether changes apply to this most recent label, all open windows, or future labels. I'll briefly show the XY plot format and change the x-axis labels to column labels rather than numbers from the file to demonstrate. Now I'll close the Omics window and demonstrate animation. To begin, I'll just press the Start button. Now, every 4 seconds, the overlays in the cellular overview will be updated to the next time point, and the slider will move to indicate the change. I'll drag the control panel off to the side and focus on the TCA cycle and L-thymine degradation pathway. We looked at earlier. And the animation shows that after the increase in oxygen levels, genes responsible for a portion of the TCA cycle show increased expression, while for the L-thymine degradation step is downregulated. I'll increase the speed so time steps are easier to see. I'll stop the animation and mention the 2 sliders in the control panel, which filter values that are included in the overlay. As I slide them back and forth, reactions where the Omics value is out of range lose their highlighting. Now I will switch tabs and show the pathway table. As before, the top of the page includes a description of perturbation scores and the color scale. The table itself has changed somewhat. In addition to the pathway name, and diagram, the perturbation score has been replaced by a differential perturbation score and a new column with a graph of perturbation scores at each time point. Columns for genes and enzymes is unchanged, but the pathway diagram itself has a row of colored boxes representing the time point for each gene rather than a single box as before. The differential perturbation is a measure of how much the pathway activity changes over time. Unsurprisingly, the L-thymine degradation pathway we looked at in the overview diagram is here. Likewise, the super pathway that includes the TCA is among the top 20 pathways. That concludes this introduction to the Omics overlay in BioCyc. As you may have noticed, There are several other ways to load data and display it that we didn't cover in detail. These other options are documented either with the info buttons in the dialogues or in the online BioCyc manual, but they all work with the visualization tools I've demonstrated. I hope you have found this presentation useful, and thank you for your attention.